आगे जावा माँ माँ सरगा माँ
क्लास के अटेंड
Please wait. I'm going to share the link, share this screen. Yes. So we wait 1 or 2 minutes for the rest of the students to join. In the previous class, this laws of motion part is not completed. Now I am going to complete that one. And again, I'll complete one more chapter, mechanical properties of solids. Today evening, I will share these 3 chapters, synopsis as well as the problems. So first I have to mark these answers. That's why I didn't share immediately. Okay. We'll start. An airplane executes horizontal loop at speed of 720 kilometers per hour with its wings banked at an angle of 45 degrees. What is the radius of the loop? Here, banking of the roads or banking of the tracks, railway tracks, will be required for the vehicles to turn in circular path. To move in the circular path, banking of the roads will be there. It means what? Outer edge of the road will be elevated. Outer edge of the road will be raised up. Then necessary centripetal force they'll get. What happens? Outer wheels they'll rise up. Accordingly, road or the track should be raised. That should be there. That we call angle of banking. How much that angle is to be raised, that depends upon the radius of the circular path. Fine. What did they give? An airplane executes horizontal loop at a speed of 720 kilometers per hour. The speed of that airplane is given 720 kilometers per hour. but we need that in meters per second. To convert kilometers per hour to meters per second, we have to multiply with 5 by 18. Then 18 that will get cancelled in 72. How many times? 4 times. And 0 is there, 40. So 18 that cancel is 72, 40 times. 40 into 5 will be 200. 200 meters per second. Velocity V is equal to 200 meters per second. They have given angle. The banking angle is given. What is the banking angle? Theta is equal to 45 degrees. What is the radius of the loop? If the acceleration due to gravity is 10 meters per second square, what is the radius of the loop they have asked? Banking, angle of banking, the formula when we take angle of banking, tan theta, angle of banking tan theta is equal to V square divided by RG. V square divided by RG. R for radius of the circular path. Then what we have to calculate? R is to be calculated. Therefore, R is equal to V square by G tan theta. V square divided by G tan theta. Then R is equal to, what is V? V for velocity. It is 200 meters per second. 200 whole square whole divided by G is 10 into tan theta. So tan 45. Tan 45. Then R is equal to 200 whole square is there. 200 into 200 divided by 10 into tan 45 will be 1. This 10 will get cancelled. 0 and 0 gets cancelled. 2 2s are 4. 2 2s are 4. Therefore, R is equal to 4 into 1, 2, 3. 4 into 1000 we may write. 1000 meters. Our radius R is equal to 4 into. This 1000 we may write as a kilometer. 1000 will be equal to 1 kilometer. Therefore, 4 kilometers. The radius of the circular path is 4 kilometers. Second option is correct. Right? If you want, for every problem, you may take the screenshot. I will share this only this answer key. I will share it. If you want, I have to write on the A4 sheet and I have to share you this solutions also. I'll try to share these solutions also because it may be difficult to take the screenshots and to revise. Means what, you have to go and revise them. It is better if you are able to save the screen. Right? I'm going to next problem. A person is driving a vehicle at a uniform speed of 5 meters per second on a level curved track of radius 5 meters. The coefficient of the static friction between the tires and the road is 0.1. Will the person will the person slip when taking turn with the same speed? Acceleration due to gravity, it is taken as 10 meters per second square. So person, whether he will slip if the speed of this one is how much? 5 meters per second is there, and radius of the circular path is 5 meters. Then will he slip or not? They have asked. Or when there is a possibility for slipping. Given data, when we say, what is that given data? uniform speed. Speed of the person is given 5 meters per second. Next, a radius of the circular path is given. Radius of the circular path is 5 meters. Coefficient of the static friction. Mu is given as mu s, s for static friction, 0.1. While that slip taking turn, acceleration due to gravity is given as 10 meters per second square. This is the data they have given. And asked to calculate whether the person will slip while taking turn on this curved road. So condition for slipping. So if the condition to avoid that slipping, what is the condition? We check first. Person will not slip if this is a condition. The person will not slip if v square is less than or equal to mu s rg. This is the condition. If v square is less than or equal to mu s rg, then he won't fall down, he won't skip. We'll calculate. V square is less than. Mu s is how much? 0.1. 0.1 into r is given as 5. G is taken as 10 meters per second square. Therefore, V square is less than or equal to 0.1 into 10 will be equal to 1. 1 into 5 will be equal to 5. So V square is less than or equal to 5. V square is less than or equal to 5. So if it is V square is less than or equal to 5, he will not slip. Then when he will slip, they have asked it. When the person will slip, in the options, the person will not slip condition is not there. When the person will slip, we have asked it. So V square is less than or equal to 5, he won't slip. So velocity is less than, V square is less than that of these 5 meters per second, he won't slip. But if the velocity is greater than this 5 meters per second, definitely it's greater than. If the velocity is greater than this, he will slip. So reverse we have to take. If velocity v square is greater than 5 meters per second, the person will slip. So a person will slip if v square is greater than 5 meters per second. This is the answer for it. Okay, next problem. In a lift moving up with an acceleration 5 meters per second square, a ball is dropped from a height of 1.25 meters. The time taken by the ball to reach the floor of the lift is approximately, if the acceleration due to gravity is 10 meters per second. In a lift which is moving up, the acceleration of the lift is given as 5 meters per second square. A ball is dropped from a height of 1.25 meters. The time taken by the ball reach the floor of the lift approximately. So what is the time it takes to, what is the time it taken by the ball to reach the floor of the lift approximately, they have asked. So the time taken by a body to cover a height h is approximately g is then time taken, acceleration due to gravity g is given as 10 meters per second. So the time taken by the body from a height h is square root of 2h by g, but it is moving as that lift is moving with an acceleration we have to write different form, means acceleration also we have to add. So that what is that? Lift is moving up with an acceleration here. Let us suppose this is a lift. Lift is moving up with an acceleration here. And the body is dropped. In that body is dropped. Time taken by the body to fall down to a height h. Time taken by the body to fall a height h is 2h divided by g. General equation. But it is moving with an acceleration a. That's why we have to add a also. Then what is that? Time taken by the dropped body with an acceleration, a ball. Time taken by the ball to reach the ground is t is equal to square root of 2h divided by g plus a. Square root of 2h divided by g plus a. Therefore, time period t is equal to square root of 2 into, what is the height they gave? 1.25. 1.25 divided by g is 10. 10, and the acceleration is given as 5. Therefore, t is equal to square root of 2 into 1.25 will be equal to 5, 2.5. 2 into 1.25 will be equal to 2.5 divided by 10 into 10 plus 5 will be equal to 15. In 15, 2.5 will get cancelled 6 times. Therefore, time period t is equal to 1 divided by square root of 16. So, square root of 4 means 2. Square root of 9 means 3. Square root of 6 is in between 2 and 3. Therefore, t is equal to 1 divided by square root of 6 will be equal to 2.44 like that. Square root of 6 will be equal to 2.44. Therefore, 1 by 2.44, 1 by 2.44 will be equal to 0.4. So time taken by the ball to fall to the floor of the lift is 0.4 seconds. So time taken by the ball to reach the floor of the lift is 0.4 seconds. Okay, I'm going to next problem. A block kept on a rough surface starts sliding when the inclination of the surface is theta with respect to the horizontal. Coefficient of the static friction between the block and the surface is, actually one block is dropped on an inclined plane. That will say angle of repose. Whenever we take the angle between the horizontal and the inclined plane, this is the theta is the horizontal angle between the horizontal plane and inclination. Then if we keep the body on it, depends upon this angle. If this angle is less, sliding won't be there. So at which angle this body slides down on the inclined plane, that angle is called as the angle of repose. For example, this is the body and the angle is like this. Body is there. Angle is taken as theta, body is like this. And then if you drop the body, then at this angle from the inclined plane, it may not slide. If we increase the angle, it's at one angle, at certain angle, it starts sliding. That angle is called as the angle of repose. Once again, I'll repeat. If the body is placed on the inclined plane, inclination is like this, body may not slide. On increasing that angle with the horizontal, it starts sliding. At which angle the body starts sliding on the inclined path, This angle should be with the horizontal. Okay, so this angle should be with the horizontal. At which angle it starts sliding, that angle we have to take as angle of repose. This angle of repose will be equal to angle of friction. Angle of repose or angle of friction, both will be same. Angle of repose is equal to angle of friction. That is, angle of friction or angle of repose is equal to tan phi or tan theta. Therefore, the coefficient of the static friction between the block and the surface is mu s is equal to tan theta. We have to take tan theta is the answer for it. Tan theta is the answer for it. Angle of friction is mu s is equal to tan theta, or tan theta is equal to mu s. And angle of repose also same. Angle of repose is equal to mu s is equal to tan theta. That's why tan theta is the correct option for it. Next problem. A body of mass m is traveling with velocity u. When a constant retarding force F is applied, it comes to rest after traveling a distance s1. If the initial velocity is taken as 2u, if the same force F, with the same force F, the distance traveled before it comes to rest is s2, then relation between s1 and s2 they have asked. What is the condition? It is given a body of mass m is traveling with a body of mass m is traveling with a velocity u. When constant retarding force F is applied, it comes to rest after traveling a distance s1. If the initial velocity is 2u, with the same force, then distance traveled before comes to rest is s2. Here two different cases are there. A body of mass m is there that is moving with the velocity u. Then it comes to rest when the brakes are applied. It comes to rest after traveling a distance s1. It will come to rest. When the force F is applied, the body of mass m is there. When the force is applied, on it, it covers a distance s1, and initial velocity is taken as u, and final velocity is taken as 0. This is the first case. The same they are saying the block of mass m is there. Whenever it moves with double of the velocity, same force is applied and it moves with the double of the velocity. F is the applied force, same force applied on it. Then final velocity will be 0 in this case also. Distance moved is taken as s2. What is this distance they have asked? From the equations of motion, we write s is equal to ut plus half at t square. But time period we don't know. That's why we cannot use this. We cannot use that one. Then whenever we come to this, v square minus u square is equal to 2as. From equations of motion, we'll write v square minus u square is equal to 2as. As the final velocity is equal to 0 minus u square is equal to, when the velocity is decreasing order, acceleration is called as the negative acceleration. 0 minus u square is equal to minus 2as. So minus u square is equal to minus 2as. Both sides will cancel minus. Then what is there? 2as is equal to u square. Then s is proportional to u square. This is the condition. S is proportional to u square. S is proportional to u square. From this we will write S1 divided by S2 is equal to U1 divided by U2 whole square. And S1 we don't know, that is taken as S1 only. S1 by S2 is equal to U1 is equal to U, U2 is equal to 2U whole square. Both numerator and denominator U will get cancelled. Therefore, S1 divided by S2, S1 divided by S2 is equal to 1 by 2 whole square means what? 1 by 4. Therefore, S2 is equal to this. If you bring to the left side, S2 is equal to 4S1. That's why fourth option is correct. Please take the screenshot. Next problem. A person throws ball into air vertically upwards in regular intervals of time, 1 second. The next ball is thrown when the velocity of the ball thrown earlier becomes 0. The height to which the ball raised is. The height through which the ball raised is. We'll say juggler. In the circus, one person, he throws the balls in the regular intervals of time. He plays with the balls. He'll throw the first ball. Whenever it reaches the maximum height, at the maximum height, velocity will be 0. When he throws the ball upwards, when it reaches to the maximum height, he throws other ball. The time interval between one ball to other ball is 1 second. The time interval between one ball to other ball is 1 second. Then they are asking how much amounts, what is the maximum height reached? What is the maximum height reached? If we project the next one velocity, if acceleration due to gravity is 10 meters per second square, a person throws balls into air vertically upwards at regular intervals of time. Each one is for 1 second later he throws another one. That means after 1 second it reaches to that maximum height. At the maximum height, velocity will be 0, right? So there we will take time period is given. Time period is given as 1 second. T is equal to 1 second. What is the data? T is equal to 1 second. Final velocity will be 0. V should be 0. Acceleration A is equal to minus 10 meters per second square. A is equal to G, or we'll write directly. A is equal to minus G. G is equal to 10 meters per second square. Then what is the maximum height reached? What is the maximum height reached? They have asked it. So then velocity V is equal to U minus GT. V is equal to U minus GT. Then final velocity is 0 is equal to U is U only minus. They didn't give that we have to calculate velocity. Then afterwards we'll calculate height. So U is equal, V is equal to 0. That is 0 is equal to U minus G. We will take 10 meters per second square T, and a time period is given as 1 second. Therefore, if you bring it to that left side, minus u is equal to minus 10. Both sides will cancel. Then u is equal to 10 meters per second. U is equal to 10 meters per second. Afterwards, we'll take that maximum height reach. We have to calculate from another equation. V square minus u square is equal to 2as. From the equation, v square minus u square is equal to as. And this final velocity is 0. 0 minus u square is equal to 2g h maximum we will write. As it is moving upwards, a is equal to minus g. Minus u square is equal to minus 2g into h maximum. There minus gets cancelled. h maximum is equal to u square divided by 2g. Therefore, h maximum is equal to u square. U square means what? 10 whole square. 10 whole square divided by 2 into 10. That will be equal to 10 whole square means 100. 100 divided by 20. 20 that cancel in 100 how many times? 20 that cancel in 100 5 times. Therefore, maximum height reached, h maximum is equal to 5 meters. H maximum is equal to 5 meters. Right? I'm going to next problem. The resultant of the two forces acting at an angle of 120 degrees is 10 kg weight and is perpendicular to one of the forces. The force is resultant of the two forces. They are acting at an angle of 120 degrees. Let us suppose P bar and Q bar are the two vectors. This is the P bar and this is the Q bar. Angle between P bar and Q bar is 120 degrees. If we keep this vector is the right angle to it. This is the resultant vector. Resultant vector is a right angle to it. Then it makes angle 30 degrees. It makes angle 30 degrees. This is that I have taken. This is also, let us suppose F1 bar and F2 bars like that. If I take, this is F1 bar and this is F2 bar. Then this is also taken as F1 bar. This is also taken as F1 bar. Now we have to take this. Resultant is given as, R is given as 10 kg weight. Resultant is taken as 10 kg weight. Then angle with the perpendicular angle theta is given. Theta is 30 degrees. So theta is equal to 30 degrees. Theta is equal to 30 degrees. And R is equal to 10 kg weight. First I am writing 10 kg weight. And theta is equal to 30 degrees. Okay. Then tan theta is equal to, tan theta is equal to, from this triangle O A, B, if I take from this triangle, this is the opposite side, this is the adjacent side. So tan theta is equal to opposite side by adjacent side. Then on bringing this to left side, F1 is equal to, on bringing this side, F1 is equal to R tan theta. R tan theta. F1 is equal to R tan theta. Therefore, F1 is equal to R is taken as a 10 into tan theta. So tan 30. Tan 30. So F1 is equal to 10 into tan 30, 1 by square root of 3. Therefore, F1 is equal to 10 by root 3 kg weight. 10 by root 3 kg weight. 10 by root 3 kg weight. This is the force. This will take. Okay. 10 by root 3 kg weight. This is. Now, one more problem. I'll solve it and afterwards I'll go for next chapter. A block of mass 2 kg is placed over a block of another mass. A block A of mass 2 kg is placed over a block B of mass 8 kg. The combination is placed on a rough horizontal surface. If G is 10 meters per second square, coefficient of the friction between B and the floor is 0.5. Coefficient of the friction between A and B is 0.4 and the horizontal force is 10 newtons is applied on 8 kg block. Then the force of friction between A and B is in between A and B. They have asked it what is the force of friction. As this is taken as it is the frictional surface. It is that frictional surface. In between these two, frictional force will be there. And here also some frictional force will be there. As it is mentioned, coefficient of the friction between these two is taken as coefficient of friction mu1. Mu1 is equal to 0.4. And coefficient of friction here, mu2, if I take that, mu2 is equal to 0.5. Masses are, they are provided. Then applied force is 10 newtons. F is that 10 newton source. Then mass of the first block is given 2 kg. Mass of the second block is given as 8 kg. We'll take M1 is equal to 2 kg and MA is equal to, we'll write instead of M1. MA is equal to 2 kg. MB is equal to MB is 8 kg. Then coefficient of frictions mu1, mu2, they are provided. And applied force is taken as 10 newtons. F is given as 10 newtons. Then what did they ask? What is the coefficient of, what is the frictional force? What is the force of friction between A and B? In between A and B, what is the force of friction? They have asked it. So the frictional force between the block B and the floor we will see first. Based on this, the frictional force will be there between the A and B. So then the frictional force between the blocks block B and the surface and the surface. That will take F is equal to, right. Take F is equal to mu 2 into MA plus MB into G. Mu 2 into MA plus MB into G. Therefore, F is equal to mu 2 is how much? 0.5. 0.5 into MA is equal to A is 2 kg. MA is equal to 2 kg. MB is taken as 8 kg into G. G is 10 meters per second square. Therefore, F is equal to 0.5 into 8 plus 2, 10. 10 into 10. This is. So F is equal to 10 into 0.5 will be equal to 5. 5 into 10. Therefore, frictional force, total frictional force, it is 50 newtons. The frictional force acting on the system is 50 newtons. This is less than the force applied. Applied force is how much? Only 10 newtons. So as the frictional force is as the applied force, will say that. As the applied force is greater than, sorry, less than, as the applied force is less than, as the applied force is less than the frictional force. Less than the frictional force. As the applied force is less than the frictional force, in such case, as the applied force is less than the frictional force, then there is no frictional force between body A and B. Force, there is no frictional force, or there is no frictional force between the bodies A and B. In between A and B, there is no frictional force. 0. This is our answer. Okay. Now, I am going to start that other chapter. This chapter is once. See, this chapter is mechanical properties of solids. Mechanical properties of solids. This is the chapter. It is the molecular phenomena. Mechanical properties, the molecular phenomena. So in this, we have to take basic concepts. What are that? Deformation force. A force that changes the shape, size, or simply configuration of the body is called as the deformation force. A force which changes the shape, size, or simply configuration of the body is called as the deformation of force. And let us suppose if it is a spring. This is that spring. It is the spring. If the spring is stretched, then the force applied is called as that deformation force. The force is called as the deformation force. Then what happens on applying that, increasing it, its length is increased. Its length is increased. Then its length is increased. Then no need to bring back ourselves to the original dimensions. If you withdraw, the applied force is there. Applied force is there. If the applied force is withdrawn, again it will come back. Again it will come back and comes to the same length. So in opposite direction, a force will be developed. That force will say, the force that will say that it is the restoring force. A force that increases the length or configuration of the body is called as the deformation force. To bring back to the original dimensions, a force is there. That force we call as the restoring force. That force we call as the restoring force. See, stress is that ratio of the change in length to original length. Let us suppose this is a wire. A wire is suspended. A wire is suspended. A wire of length L is suspended. Then on applying the load, the length of the wire is extended. On applying the load, the length of the wire is extended. E for extension or elongation, we'll say that. Actual length of the wire is taken as L, and on applying the load, length of the wire is increased. This is that new length of the wire. So this is called extension. This length of the wire is increased. The length of the wire is increased. Then strain is the ratio of change in dimensions to original dimensions. Change in dimensions to original dimensions. This is called as the strain. Strain is that change in dimensions of original dimensions. If it is along its length, we'll say that so longitudinal strain. Please mute. Please mute. Longitudinal strain is equal to change in length by original length. Next, tangential. Tangential strain is equal to change in area divided by initial area. So volume strain. Volume strain is equal to change in volume divided by initial volume. These are okay. These are the types of the strain. Strain has no unit. It has no unit. Unit is not there for it, right? Next, stress. Restoring force per unit area is called as the stress. Unit of the stress is force per unit area. Its unit is a Newton per meter square. So stress. Stress is also three types: longitudinal stress, tangential stress, shearing or tangential stress. Third one is volume or bulk stress. For all of them, force per unit area is the formula for all, right? So when we take that, most important one, based on this, many times problems are there in all type of competitive exams. Then Young's modulus. Young's modulus is the ratio of longitudinal stress to longitudinal strain. It is the ratio of the longitudinal stress to longitudinal strain. Longitudinal stress, force per unit area, divided by longitudinal strain, change in length by vertical length, E by L. On writing reciprocal, we will get Young's modulus Y is equal to FL divided by AE, where if you take a wire of length L is suspended like this, area of cross section is taken as A. For that, weight is taken, force is taken as a weight. A wire of length L is there. This length L and area of cross section A is suspended. Length L and area of cross section A is suspended. Then weight of this one acts in the downward direction. So this weight is nothing but force. Force is equal to mg, we may write. A for area of cross section, that will be equal to pi r square. On substituting this, Y is equal to mgl divided by, in the place of F, we'll write M. For this, a mass M we are attaching. Mgl divided by pi r square into E. Mgl divided by pi r square into E. Mgl divided by pi r square into G. This is the expression for the Young's modulus. This Young's modulus decides that strength of the material. So Young's modulus is infinite for a perfectly for a solid. For solids, Young's modulus is infinite. Young's modulus is infinite for the perfect rigid body. For the perfect rigid body, Young's modulus is infinite. Young's modulus, if it is more, it is a good matter, right? So then Young's modulus we can write in different form, in different ways. Then how? Young's modulus of the two wires, they are connected. Otherwise, Young's modulus formula have written Y is equal to FL divided by AE. I wrote other formula. What is that? Other formula, Y is equal to FL divided by Y is equal to FL. In the place of this, MGL divided by pi r square into E. Or this we may write in terms of Y is equal to FL square divided by VE. Or we may write Y is equal to FL square. Volume is then volume, V for volume. Volume is density is equal to mass divided by volume. Then volume is equal to mass divided by density. So this is FL square divided by M by D. This is FL square D divided by M, we may write. Or Young's modulus Y is equal to, we may write F V divided by A square into E. Or this formula, we may write it as, we may rewrite it as Y is equal to FV divided by pi r square into E also. Pi square r power 4, as A square is there, we'll get pi square r power 4 E. Pi square r power 4 E, that is. So y is equal to fe divided by pi square r power 4 into e. And then fe divided by r square power 4 e. Otherwise, y is equal to f density is equal to mass by volume. Then volume is equal to mass divided by density. So Fm divided by a square dE. Like this, we can write different formulas for the Young's modulus. Let us suppose two wires are connected. Two wires are there, and the two wires they'll have Young's modulus. The two wires have the Young's modulus Y1 and Y2. They are connected in series to a load of mass M. Let us suppose the two wires. This is a one wire of the length L and the area of cross section A. Two wires of the same length and the same area of cross section. They are same area of cross section. They are connected in series. Their Young's modulus are Y1 and Y2 are the Young's moduli, and for them a load M is attached. Then effective Young's modulus of this one we have to take. What is the effective Young's modulus of the combination? So for that, we will take that effective Young's modulus of the system is Y is equal to 2y1 y2 divided by y1 plus y2. Y is equal to 2y1 y2 divided by y1 plus y2. Y is equal to 2y1 y2 divided by y1 plus y2. This is the effective Young's modulus of the system. This is the effective Young's modulus of the system, right? 2y1 y2 divided by y1 plus y2. This is regarding that Young's modulus. When we go to that next rigidity modulus, ratio of the longitudinal stress to longitudinal strain is called as the rigidity modulus. Rigidity modulus. This is the ratio of the longitudinal stress to the longitudinal strain we will take. Ratio of the longitudinal stress to that longitudinal strain is called as. So sorry, one more I forgot. Afterwards I'll come again. The two wires, they are connected in parallel, whose Young's modulus are taken as y1 and y2. Parallel combination I did explain. Let us suppose two wires of the same length and the same radius. They are connected parallel. They are connected parallel, and it is connected to a load of mass M. For this, a load of mass M is attached. For this, a load of mass M is attached. Young's modulus is taken as a y1 and Young's modulus is taken as y2. Y1, y2 are the Young's modulus. Then the effective, if we take that effective Young's modulus, y is equal to y1 plus y2 divided by 2. Effective Young's modulus is equal to y, and y is equal to y1 plus y2 divided by 2. This is the effective Young's modulus of the system. Okay. So one more. A wire L is suspended vertically. Let us suppose a wire of length L is suspended vertically. If length of the wire that increases, what happens? If the length of the wire increases, its own weight will extend it and the wire will be broken. Its own weight only causes for breaking of the wires. Then length should be less. What is the maximum length? They'll ask it. So the maximum length of the wire that should be suspended vertically, that is hung vertically to avoid extension due to its own weight. So maximum length of the wire they'll ask. Maximum length of the wire is equal to breaking stress. Breaking stress divided by dg. The maximum length of the wire is to be connected is breaking stress divided by dg. D for density, G is acceleration due to gravity. Maximum length L is equal to breaking stress divided by dg. There, whenever we take that, if due to its own length it is extended, we didn't maintain that this length, and the length of the wire is more. So if the wire is extended, the extension depends upon the Young's modulus of the wire. So E is equal to L square dg divided by 2y. For example, due to a length L, due to its length L and density D and Young's modulus Y are there. Density of the material is taken as D, length of the wire is taken as L, Young's modulus is taken as Y. So if length is greater than that minimum length, then what happens? It will expand. It will expand. Means what? It will extend. Length of the wire will be increased. So then we'll take that extension in it. E is equal to, due to length L and density D, Young's modulus Y, the extension in the length is E is equal to L square dg divided by 2y. E is equal to L square dg divided by 2y. This is the extension due to its own weight. So whenever a load of mass, a mass is connected to a wire. For a wire, a mass M is attached. Then due to its mass, what happens? There will be extension. There will be some extension. It might be there. So that extension will say that elongation E. This is called as the elongation. So this one, if it is dipped in the liquid of density dl, the same wire, it is dipped in the density of the liquid dl. This is dipped in the that liquid. Liquid of density dl. Liquid of density dl. So right. Liquid of density dl, it is there. Then body density is taken as a dp. Then here elongation is E. In the water also elongation, extension will be there, that is E dash. So this E dash will be equal to, E dash is equal to E into 1 minus dl divided by db. 1 minus dl divided by db. So elongation E is equal to, elongation E is equal to, E dash is equal to E into 1 minus dl divided by db. This is that elongation whenever it is dipped in the liquid, right? When we come to that rigidity modulus, whenever we take that rigidity modulus is taken as eta. Eta is equal to tangential stress divided by tangential strain. Then F by A theta we will take. F by A theta, rigidity modulus. This theta is called as the shearing angle. Next, bulk modulus. When we come to that bulk modulus, B is equal to, bulk modulus B is equal to bulk stress divided by bulk strain. F by A whole divided by bulk stress by bulk strain, delta V by V we will write. That we will write bulk modulus B is equal to FV divided by A into delta V. This is the bulk modulus. So instead of this, we may write force per unit area will be equal to pressure. That's why P is equal to pressure. B is equal to pressure P divided by dV divided delta V divided by V. Delta V divided by V. Therefore, we'll take that B is equal to PV divided by delta V. PV divided by delta V. Let us suppose bulk modulus is taken as K. K for the bulk modulus. K is taken as the bulk modulus. Then a body or a rubber ball is taken to a depth. A rubber ball is taken in a lake. This is a lake. A rubber ball is taken to a depth D, depth H from the surface of the liquid. What is the decrease in its volume? What happens at the depth H? The volume pressure will be more, then volume will be decreased. So the decrease in volume of the rubber ball whenever it is taken from surface to that depth H. This is a problem. This based on these problems are there in previous CET. Then a rubber ball of mass M is there and volume V is there. This is taken to a depth H from the surface. Then the decrease in volume we have to calculate. What is the decrease in volume? That we have to calculate. So therefore, decrease in volume bulk modulus, first we'll take that. This is from this we'll write that. So bulk modulus is taken as K. Here it is taken as K. K is equal to PV divided by delta V. So on bringing this to left side, delta V is equal to PV divided by K. There, delta V is equal to pressure P is equal to rho G H or H rho G. Like we may write like this also. H rho G into V divided by bulk modulus K. Like this we will take. Okay. Whenever we take this, delta V is the decrease in volume. Next, Poisson's ratio. Poisson's ratio. What is Poisson's ratio? It is that ratio of the tensile stress to longitudinal stress, we'll say that. So Poisson's ratio sigma is equal to minus delta R divided by R divided by E by L. So along with that length, if it is increasing, radius also that changes. Then that is called as the tensile. Tensile, we'll say that along with that length, if it is increasing or changing the radius or diameter, that will say sigma is equal to minus delta R by R divided by E by L. This is a Poisson's ratio. So this sigma will have theoretical value. Theoretical value of sigma lies between theoretical values of sigma lies between -1 and 0.5. Practical value will take practical value of sigma. If you take that, it lies between 0 and practical value of sigma lies between 0 and 0.5. Practical value that lies between 0 and 0.5. Like this. This is the Poisson's ratio will take. Next. a wire is taken. This is a wire. This is a vertical wall, a vertical rigid support like that. It is the vertical rigid support. For this, if I connect a wire, length of the wire is taken as L. If I twist this wire, if radius of the wire is taken as R, if I twist this wire, there will be a shearing in it. Here at this end, we have to twist it. Whenever we twist it, at this end, whenever we twist it, then a shearing angle will be there. That shearing angle is taken as a phi. Phi is the angle of shearing. Phi is that angle of shearing. The shearing angle is taken as a phi. Then it is twisted to an angle theta. Then angle of the shearing, if you want, this phi into L will be equal to R theta. From that, angle of shearing will be, so phi into L is equal to R theta, and shearing angle phi is equal to R theta divided by L. Shearing angle phi is equal to R theta divided by L. This is shearing angle. Okay, I am going to start this numericals from this chapter. Which of the following has the highest elasticity? Steel is more elastic than rubber. Which is more difficult to strain? It is called as the more elastic. Rubber easily will be strained. That's why it is not elastic. It is not a more elastic body than rubber, than steel and other metals. Steel is more elastic than rubber or copper or sponge, because which is more difficult to strain, that is more elastic. Which is more difficult to strain is called as more elastic body. So it is difficult to strain that steel. That's why it is the more elastic body or highest value of the elasticity. Then 4 wires are there. The following 4 wires of length L, radius R, radius small r are of the same material. Which of these will have the extension? Which of these will have the largest extension? Which of these will have largest extension? So the formula to calculate this extension, elongation. What is the formula for the Young's modulus? Young's modulus Y is equal to FL divided by AE. This is the area of cross section. That's why in the place of a radius is given. That's why area will be written as pi r square into E. From this, if I write E as subject, E is equal to FL divided by Y into pi r square. E is equal to FL divided by Y into pi r square. Okay, this is the formula for the extension. Extension E depends upon length of the wire and the square of the radius. From this we will write first one, E is equal to L divided by R square. There E is equal to L divided by R square. Then E is equal to, what is the length L? 100 centimeters. So 100 centimeters means 1 meter divided by 0.2 millimeters. That I am taking 2 into 10 power minus 8. Okay, E is equal to 10 power minus 8 will be common in all of them. That's why E is equal to 1 by 2. E is equal to order of 1 by 2. This is the first case. Next one, whenever we take next case, whenever we take E is equal to L divided by R square. Then E is equal to, what is the length L in the second case? 200 meters, nothing but 2 meters. divided by r square. Sorry, square is also there. It is given as 0.2 millimeters. This 0.2 millimeters, I'll write it as 0.2 millimeters. I write 2 into 10 power minus 10 power minus 4 meters. This is 4 into 10 power minus 4 meters. This is 6 into 10 power minus 4 meters. This is 8 into 10 power minus 4 meters. Minus 4 is common all of them, in all of them. That's why I'll take only 2, 4, 6, 8 because it's common ratio. We are taking that common. So then E is equal to 1 by 2 whole square. 1 by 2 whole square. Then E is equal to 1 divided by 4. 1 divided by 4. This is the first one. And the second one. And the second one, whenever we take. In the second, E is equal to L divided by R square. What is L? L is equal to 200 centimeters, nothing but 2 meters. It will be equal to 2 meters. E is equal to 2 meters divided by R value. I am taking only 4 because this 10 power minus 4 is a common for all of them. That's why no need to take it. So this is E is equal to 2 divided by 1 by 4 whole square. 1 by 4 whole square. E is equal to 2 divided by 4 fours are 16. 4 fours are 16. 2 that cancel 16. How many times? 8 times. Therefore, elongation E is equal to 1 by 8. Elongation E is equal to 1 by 8. Next one. Third one. Elongation E is equal to L divided by R square. In this, what is given? Length is given as 300 centimeters, nothing but 3 meters. 3 meters divided by. This is taken as 6. So 6 whole square. Then E is equal to 3 divided by 36. That will be E is equal to 1 by 12. 1 by 12. Next, fourth one, when we take. This is a way we have to check all the 4 options. Fourth one, when we take that E is equal to L divided by R square, then E is equal to, what is L? L is taken as 4 divided by R square. R square is 8 whole square. Then E is equal to 4 divided by 64. That will be 16. Therefore, E is equal to, E4 is equal to 16, or E is equal to 16. E is equal to 1 by 16, which is that largest extension they have asked. So largest extension is largest extension is 1 by 8, 1 by 12. Which of the wires has that largest extension they have asked? Which 300? See option 1 by 12. No. Sorry, 1 by 12 it is there. You are getting. Yes, A is first option is correct. This is correct. L is equal to 100 centimeters, R is equal to 0.2 meters, then 1 by 4. This is correct. This is correct. Next problem. The ratio of the hydraulic stress to the corresponding strain is called as hydraulic stress to the corresponding strain is called as the bulk modulus. It's from theory part. Next, a spring is stretched by applying a load to its free end. The strain produced in the spring is longitudinal as well as that shearing. So a spring is stretched by applying a load to its free end. The strain produced in the spring is longitudinal as well as the shearing. Longitudinal and shearing. Next. Young's modulus is defined as the ratio of Young's modulus is defined as the ratio of Young's modulus is defined as a ratio of this bulk, not hydraulic now. So tensile stress and longitudinal strain. Ratio of the tensile stress and longitudinal strain. Young's modulus is defined as, this is not sharing, this is not a hydraulic, hydraulic means volume, hydraulic. So bulk stress is not. So tensile stress and longitudinal strain ratio. So tensile means along its length. So tensile stress and longitudinal strain ratio is called as the Young's modulus. Next, two wires A and B are stretched by the same load. If the area of cross section of A is double than that of B, then the stress in B is here according to definition of the elasticity. Stress is directly proportional to strain according to definition of the elasticity. Stress is directly proportional to strain. Stress is directly proportional to strain. It is for the elastic bodies only. Stress is directly proportional to strain. If stress increases, strain also increases. Then we'll write that stress is equal to what? Restoring force per unit area. Actually, they have asked what is the then stress on B is. What is the stress on B? They have asked it. Okay. Two wires A and B stretched by the same load. If the area of cross section of A is double that of B, then the stress is. Otherwise, directly we may write stress is equal to restoring force per unit area. Stress is equal to restoring force per unit area, and the stress is inversely proportional to area of cross section. So from this we will write, stress 1 divided by stress in the second case. Stress in the second case is equal to A2 divided by A1 area. So then two are there. Instead of A and B, I am taking 1 and 2 because here area represents area. That's why A and B stretched. If the area of cross section of A is double, area of cross section of the first one, A1 is 2 times of the area of cross section of that second wire. So A1 is 2 times of that A2. Then what is the stress on B? What is the stress 2 they are asked? Stress B is nothing but what is the stress 2? AB it may give confusion. That's why I have written like this. So stress in the first case divided by stress in the second case is equal to A2 by A1. That is equal to A2 is taken as A and A1 is taken as 2A. Both in numerator and denominator, A and A gets cancelled. That will be equal to 1 by 2. Then stress in the second case is equal to 2 times the stress in the first case. So this is 2 times of that first wire, twice than that of A. B option, twice than that of A. Next one, Young's modulus of perfect rigid body is infinite. Young's modulus of perfect rigid body is infinite. Increase in length of the wire is 1 millimeter when suspended by weight. If the same weight is suspended on a wire of double its length and double its radius, the increase in length will be. Say, increase in length of the wire is 1 millimeter. E1 is taken as 1 millimeter. It is the first case. When suspended by a weight, if the same weight is suspended on wire of double of its length, first wire of length L is taken. For this, a wire of length L, its weight is added. It is added. First wire of length L, a weight is added. And the wire of double of its length. Then extension is taken as E1. Then L1 is equal to what? L1 is equal to L. L1 is equal to L. Other wire is there. Other wire, if the same weight is suspended on a wire of double of its length. Double of its length is taken. For this, same mass is attached. So then L2 is equal to 2 times of the initial length. What is the elongation E2 they have asked? What is the elongation they have asked? So from the formula, Young's modulus Y is equal to FL divided by AE. From this, we'll write that elongation E is proportional to FL L square. If the same wire is suspended, double of its length. Okay. So whenever we are taking same wire is suspended, suspended by wire, if the same wire is suspended on wire of double of its length. FL square divided by AE we have to write. Then E is proportional to L square. E1 divided by E2 is equal to L1 divided by L2 whole square. L1 divided by L2 whole square. E1 is equal to 1 millimeter divided by E2 is equal to L1 is equal to L. L2 is equal to 2L. Right? Whole square is there. Then L and L. Therefore, 1 divided by E2 is equal to 1 divided by 4. And on cross multiplication, we will get E2 is equal to 4 millimeters. E2 is equal to 4 millimeters. This is taken as E2 is taken as 4 millimeters, right? Next problem. I'll take more 10 minutes and next class for 5 minutes extra I'll take. Definitely I will share these numericals and synopsis today itself in the evening after 8 or 9 I'll share. In increase in length of the wire is, this is our see. The temperature of the wire of length 1 meter and area of cross section is 1 centimeter square is increased from 0 degree centigrade to 100 degree centigrade. If the rod is not allowed to increase in the length, the force required will be coefficient of the linear expansion is given as 10 power minus 5 per degree centigrade, and the force and Young's modulus is given as Young's modulus is 10 power 11 Newton per meter. So then we have to calculate force required. We have to calculate force needed. What is the given data? According to given data, a temperature of wire of length of the wire is taken as length of the wire is equal to 1 meter and the area of cross section A is equal to 1 centimeter square. 1 centimeter square means what? 10 power minus 4 meter square. 1 centimeter square is equal to 10 power minus 4 meter square. Then its temperature is increased. Delta theta is equal to 0 degrees centigrade to 100 degrees centigrade. They have increased. That will be difference in temperature is equal to 100. Difference in temperature will be equal to 100. Okay. Then if the rod is not allowed to increase its length, the force required will be if the linear expansion coefficient alpha is given, alpha is equal to 10 power minus 5 per degree centigrade, and Young's modulus y is equal to 10 power 11 Newton per meter square. Force is to be calculated. To calculate the force, then y is equal to FL divided by AE. Then instead of this, we have to go for thermal stress. We have to go for thermal stress. So thermal stress, Y is a thermal force, F is equal to YA alpha delta theta. YA alpha delta theta. This is called as a thermal force. This is called as thermal force. So F is equal to Young's modulus Y is given as 10 power 11. Area of cross section is 10 power minus 4. Linear expansion coefficient alpha is equal to 10 power minus 5. Delta theta is 100. Delta theta is taken as 100. So this F is equal to 10 power 11 10 power 13. It is 10 power plus 13 into 10 power 9 minus 9. So we will get F is equal to 10 power plus 13 minus 9. So 10 power plus 13 minus 9. That is equal to F is equal to 10 power 4 newtons. F is equal to 10 power 4 newtons. Next problem. A rod of length L and area of cross section capital A is heated from 0 degrees centigrade to 100 degrees centigrade. The rod is so placed that it is not allowed to increase in its length. Then the force developed is proportional to. Then thermal stress Y is equal to FL divided by AE. This force developed, thermal force F is equal to YA alpha delta theta. See, the thermal force that depends upon length is given. Length is wrong. This length is wrong. A power minus 1 is also wrong. Thermal force is directly proportional to A. Thermal force is directly proportional to area of cross section. That's why C option is correct. For this, which is correct, thermal force is directly proportional to area of cross section. Thermal force F is equal to YA alpha delta theta. YA alpha delta theta. This is YA alpha delta theta. It is. Next, an aluminum rod of Young's modulus 7 into 10 power 9 Newton meter square has a breaking strain 0.2%. The minimum cross-sectional area of the rod in order to support a load of 10 power 4 newtons. This is given aluminum rod of Young's modulus of the rod Y is equal to 7 into 10 power 9 Newton per meter square. The breaking strain is, so strain is given as 0.2%. That will be equal to 102 by 100. 102 by 100. The minimum cross-sectional area of the rod in order to support a load of force F is taken as 10 power 4 newtons. So the minimum cross-sectional area of the rod is needed. What is the area of cross-section of the rod? Then we know Young's modulus Y is equal to force per unit area into strain. Will take. Then we have to calculate what is the force. F is equal to YA into strain. Young's modulus into area of cross section into strain. Then F is equal to Young's modulus Y is how much? Young's modulus Y is equal to 7 into 10 power 9. Area of cross section A is to be calculated. Force is given. Sorry, area of cross section is to be calculated. Then we will write A as subject. So then A is equal to F divided by Y into strain. Then A is equal to F is how much? F is equal to 10 power plus 4 divided by Young's modulus 7 into 10 power 9 into strain is given as 102 divided by 100. And I'm bringing this to the numerator. Area of cross section A is equal to 100 into 10 power 4 whole divided by 7 into 102 into 10 power 9. If we bring it to the numerator, A is equal to 7 into 102 will be 7 into 102. 714 it is. 2 7s are 4. 2 7 2s are 14. 1 is there. 14 and 7 7 714 it is. So then it will be 1000 divided by 714. Otherwise 10,000 divided by 10 power 4 is that 10,000 divided by 714 into this is 100 and 10 power 9. So it will be 100 into 10 power 9. 10 power 7. Seven into 10 power 9 is fine. 102, this 100. Then 10 power 4. In simple way, other than this, it is becoming lengthy calculation. Then up to here, it's okay. I'm writing that this last steps I am writing. I'll write on a white screen for the clarity. I'm going to stop the class after this problem. Otherwise, here also we can do it. Yes, I'm taking this. Then I am going to solve the numerical here. For us, what is the given data? F is given as 10 power 4. Strain is given as 0.2%. 0.02% means 0.002. 0.2% means what? 0.2%. 2 means what? 0.2 divided by 100. That is equal to 0.002. 0.002 it is. Okay, strain is equal to 0.002. Then Young's modulus Y is given as 7 into 10 power 9. What we have to calculate? Then area is to be calculated. What is that? Area. Then area A is equal to F divided by Y into strain. Y into strain. So from that area A is equal to 10 power 4 divided by Young's modulus 7 into 10 power 9 into this is a 0.002, which A is equal to 10 power 4 divided by 7 into this is a 10 power minus 9 it will be 10 power minus 9. Before that I'll make it. Before beginning that 7 into 10 power plus 9 into this I'll write 0.002. I'll write it as 2 into 10 power minus 3. 2 into 10 power minus 3. Therefore, A is equal to this is 10 power plus 4 divided by 7 into 2 into 10 power plus 9 to 10 power minus 3. It will be equal to 10 power plus 6. If it comes to numerator, we'll write that A is equal to 10 power plus 4 and 10 power minus 6 divided by 14 divided by 14. Sorry. 2 7s are 14 only. 14. Then A is equal to 10 power 10 power minus 6, 10 power plus 4. That I am writing as 10 power 200 divided by 14 into 10 power minus 4. 6 minus 6 minus 4 it will be 100 divided by 14. Otherwise 10 by 14 it won't work. 1000 by 14 we have to take it as 10 power 4 is 10,000. 10,000 10 power minus 6, that will be okay. This way, whenever we write this, A is equal to 10 power plus 4, 10 power minus 6 will be 1 by 14. 1 by 14 into 10 power minus 2 will get it. 10 power minus 2 will get. Or A is equal to 100 divided by 14 into 10 power minus 4. Same, what did I write now? That. So this will be equal to 7 times it will get nearly 7.1 into 10 power minus 4. 10 power minus 4 meter square. Area A is equal to 7.1 and 10 power minus 4 meter square. This is the answer for that problem. Okay, I will share this in the evening. Thank you. I'm going to start the class here.
Thank you, sir.